All right, so we're going to talk now about parallel line problems using systems of equations. So a quick review on the steps for the introductory level problems. We had to identify the types of angles that we were given, identify the relationship between those angles, whether they're congruent or supplementary, use the relationship to write an equation, and then solve that equation for our variable. We're going to be using these same steps to help us get started today, but because we're working with systems of equations, things are going to be just a little bit different. So what is a system of equations? In a system of equations, you're going to have more than one variable you need to solve for and more than one equation to work with. For these examples today, we're going to have two variables, and therefore we will need two equations. An example problem might look something like this. We've got a pair of parallel lines. We've got three different angle measures given in terms of both x and y. And with that information, we can write three equations. So the first equation, using the fact that angle AHE and angle EHB are a linear pair and therefore supplementary, we can say 7x minus 8y plus 9x plus 7y equals 180. Second equation, using angle EHB and angle DKF, those are same side exterior angles, which are supplementary. So we get 9x plus 7y plus 11x plus 3y equals 180. And then our third set of angles, we've got angle AHE and DKF, which are alternate exterior angles, which are congruent. So we can say 7x minus 8y equals 11x plus 3y. Now, these equations right now are kind of big and messy looking, so we're going to simplify them a bit to put them in the form ax plus by equals c. In the first one, we'll combine like terms, get 16x minus y equals 180. Second one, we will combine like terms again. We will get 20x plus 10y equals 180. And in the third one, we'll move all the variables to the same side of the equation and get 4x plus 11y equals 0. So our first strategy for solving a system of equations is called elimination. Here's our example problem again. We had these three equations after we simplified. 16x minus y is 180, 20x plus 10y is 180, and 4x plus 11y equals 0. We can choose any two equations to use. And it's important to note that there is no wrong choice here. Make whatever choice you like best. I have chosen the first equation and the third equation. I did that because I like that the first equation doesn't have a coefficient on the y, and I like that the third equation has an equals 0. But I could have chosen the second equation and either one of the others. I will get the same answers for x and y. So this is entirely up to you to choose which ones make you happy. Now that we've got these two equations, let's notice that if we multiplied the second one by negative 4, we would have negative 16x, which is the opposite of the x value in our first equation. So our first equation is 16x minus y equals 180. And after I multiply the second one by negative 4, I've got minus 16x minus 44y equals 0. And so now I've got these two equations, and I can add them together, the entire equations, and get a new equation. When I add them together, my x's cancel out completely. Negative y minus 44y is negative 45y, and 180 plus 0 is 180. So now I've got negative 45y equals 180, which I can solve for y and get y equals negative 4. So now that I've got y equals negative 4, I had these two equations to start with. I can plug that into either one of them. I'm choosing the second one just because I like it. There's no wrong choice here. You will get the same answer either way. So when I plug that into the second one, I've got 4x plus 11 times negative 4 equals 0. And with a little bit of algebra, I'm going to get x equals 11. So we found out that y equals negative 4 and x is 11. And so our final answer is an ordered pair, x comma y. I've got 11 comma negative 4. So just a quick summary of what we did there. We're going to multiply one or both equations by a value that'll allow you to cancel a variable when adding the equations. We'll add the equations together to get a new equation with only one variable. We will solve for that first variable, plug that value into either one of the original equations to solve for the second variable, and then give your answer as an ordered pair. So that was our first of two strategy options. Second strategy option is substitution. So once again, we're looking at the same example problem. We've got those same three original equations as before, and we're again going to choose any two of them. I'm going to choose the same two I did before just because I still really like those ones. But again, you could choose whichever two of these three you like. You will get the same answers for x and y either way. So now that I've got these two equations, my goal is going to be to rearrange one of the equations to isolate one of the variables. And again, there is no wrong answer here. You can choose whichever equation you like, whichever variable you like. Personally, I'm going to choose to solve the first equation for y. The reason I'm making that choice is because the y not having a coefficient on it is going to make that nice and easy for us without any fractions. But you could do it a different way. You'll get the same answers for x and y. You'll just have more fractions on the in-between steps. So I've got this equation. I add y to both sides. I subtract 180. I've now got 16x minus 180 equals y. And so my two equations now are 16x minus 180 equals y, and 4x plus 11y equals 0. That second one has not changed at all. Now that I've got the first one as y equals whatever, I can take that expression that I've solved for y and plug it into the second equation. The fact that I'm plugging it into the other equation is important here. If I plug it into the first one, things are not going to work out nice for me. So I'm going to plug it into my other equation, the one that I haven't touched yet. And so now I've got 4x plus 11 times parentheses 16x minus 180 equals 0, taking that entire expression that y equals and dropping it into a set of parentheses where y was. I can do some algebra to solve. I distribute. I combine like terms and move stuff over. I end up at x equals 11. So I've just found out that x equals 11. I had started with these two original equations. I can plug x equals 11 into either one of them. Again, no wrong answer here. I'm choosing the second one just because I like it. So I get 4 times 11 plus 11y equals 0. And with a bit of algebra, I'm going to get us y equals negative 4 as our answer for y. So we've found out that x is 11, y equals negative 4. Our final answer, once again, is an ordered pair, x comma y, 11 comma negative 4. Notice that this is the same final answer we got before, so we used a different strategy. We got the same answer. And I would get this same answer if I used one of my other equations as well. So summary of the substitution strategy. We rearrange one equation to isolate one variable. You're going to get an expression in terms of the other variable. You plug this expression into the other equation, the one that you haven't touched yet, so that you now have an equation with only one variable. Solve for that variable, plug it into either original equation to solve for the second variable, and give your answer as an ordered pair. So the key idea is anytime you're dealing with one of these example problems, use the parallel line theorems to write equations. You're going to get 3 equations. You choose any 2 of them to use. Once you've chosen your 2 equations, you can make a choice to use either elimination or substitution to solve for your first variable. No wrong answer there. It's just whichever strategy you personally like best. And then use that value for the first variable to solve for your second variable. Your final answer is always going to be an ordered pair.